Hi, Algebra 2. This is Unit 3, Lesson 3, Linear Functions. So today we're going to do a lot of stuff that you learned last year in geometry, along with some stuff that you learned 2 years ago in Algebra 1. So to start off, there are two common forms of a line. There's a slope-intercept, and that one you worked with a lot in Algebra 1. And there's also my point slope, and that I did last year in geometry a lot. Y minus y1 equals m parentheses x minus x1. So basically in geometry, a lot of times I had a point and a slope, so I used that point, which was my x1, y1, and my slope, which was my m, and I was able to write my equation. So again, m is my slope, and b was the point on the line. That was my x1, y1. So I just needed 1 point and 1 slope. If I had 2 points, then I could use either one. Whereas in algebra a lot, you used y equals mx plus b. Again, m is still your slope, but this time my b I used was my y-intercept. But in both of these cases, slope is the average rate of change. So let's look at example 1. Consider the linear function f of x equals 3x plus 5. Determine the y-intercept of this function by evaluating f of 0. So f of 0 equals 3 times 0 plus 5. I'm plugging in 0 for x. 3 times 0 is 0, and 0 plus 5 is just 5. Okay, that is my, my y-intercept, which makes perfect sense because if I'm thinking back to y equals mx plus b, my y-intercept is my b, which in this case would be my 5. I want to find the average rate of change over the interval between -2 and 3. So basically I'm doing f of 3 minus f of -2 all over 3 minus -2. Well, f of 3, I can do this again by looking at a calculator. This one's pretty simple though, it's just a linear function. So I'm going to do this off to the side in another color just so we don't get too confused. F of 3 is just 3 times 3 plus 5, which is 14. And f of -2 is 3 times -2 plus 5, which is -1. All right, so now I'll use those in my problem. So f of 3 was 14 minus f of 2 is -1 all over 3 minus -2 is 5. 14 minus -5 is 15 over 5. So my average rate of change over that interval is 3, which again makes perfect sense because look, my average rate of change is my slope is my m, and my slope was 3. Okay, and again, I'll highlight this also. My y-intercept is my b, and that wound up being 5. Okay, so this is just showing you how the numbers in that equation, the slope and the y-intercept, we can actually find, and they wind up being the numbers, the m and the b. All right, consider a line whose slope is 5 and which passes through the point -2, 8. Write an equation of this line in point slope form. So basically, this is my x, my x1. This is my y1, the 8. And my slope, I need one more color, my slope is 5. Okay, so it's going to be y minus 8 equals my slope, which is 5, parentheses x minus, and then my x1 is -2. Well, x minus -2 is really just x plus 2. And this right here can be my answer. Can I distribute this? Absolutely, or I could just leave it just like that. All right. B wants us to write the equation in slope-intercept form, meaning I need to get y all by itself on the left with nothing else. So I am going to take that 5 and I'm going to distribute it to everything inside the parentheses, and that's going to give me 5x plus 10. And then again, I need to have that y by itself, so I'm going to add 8. So it's going to be y equals 5x plus 18. Right? But both of those are equivalent. One's in point slope form, and one of them is in slope intercept form, the y equals mx plus b. All right, exercise 3. Which of the following represents an equation for the line that is parallel to y equals 3/2 x minus 7 and which passes through the point 6, negative 8. So this is my x1 and my y1. All right, and I'm using that point slope form of a line. All right, so my x1 and my y1, this is my x1. I'm going to plug that in for x1. This is my y1. I'm going to plug that in for y1. And the thing that I'm missing is my my slope. But I actually do have my slope. My slope, if they're parallel, remember back from last year in geometry, parallel lines have the same slope. So parallel lines have the same slope. I'm going to write that down so I remember that for all the problems that I'm going to be doing. Parallel lines are two lines that never intersect. The slope is how steep they are. So it makes sense that parallel lines have to have the exact same slope. So I'm going to use a slope of 3/2. So I'm going to look at my multiple choice right now. Two of these have the wrong slope. Choice 1 has the wrong slope, and choice 4 has the wrong slope. So I'm not using them. But again, I'm plugging in my x1 and my y1. So it's y minus negative 8 equals 3/2 x minus 6. And I can see which of those has the right one, and that would be choice 3, because y minus negative 8 is actually y plus 8. And I'm leaving it just like that. I'm not distributing it. That's my answer. Done. All right, a little bit more review from what we did in geometry last year. If I give you 2 points, so a line passes through the points 5, negative 2, and 24, determine the slope of this line in simplest rational form. So my slope is the change in y over the change in x, which is just y2 minus y1 over x2 minus x1. So this is my x1, y1, x2, y2. So I'm going to have 4 minus negative 2 over 20 minus 5. And that gives me 6 over 15. And I can reduce that. They're both divisible by 3, so 2/5. Write an equation of this line in point slope form. So point slope form, this is my point slope form. I can take either point. It does not matter which one that I want to take. I'm going to take the 20 and the 4 just because they're positive numbers, and then I don't have to worry so much about signs. So y minus y1, my y1 is 4, equals the slope. The slope I just found out over here. My slope is 2/5. Parentheses x minus, and my x is 20. And that is my answer for that. They want me to write an equation for this line in slope-intercept form, which means I'm going to take what I just got, but I'm going to distribute, and I'm going to get y by itself. Slope-intercept form means I want it in y equals mx plus b. I just have to get the y by itself. So this 2/5 gets distributed, 2/5 x. Now 2/5 times negative 20 is going to be negative, let's see, 5 goes into 24 times. 2 times 4 is going to be negative 8. Okay, you can do that in a calculator if you need to. And then I'm adding 4. So I get y equals 2/5 x minus 4. Done. For what x value will this line pass through a y value of 12? So my y value is 12. So I'm just going to take that equation that I just found in part C, but I have a y value of 12. So I'm plugging in 12 for y, and I'm going to solve for x. So I'm going to add 4. 16 equals 2/5 x. And then I'm going to, if I have a fraction, I'm going to multiply by the reciprocal to get rid of it, which means I need to multiply this side by 5/2. And that gives me 40. So x equals 40. Okay, you can also put that equation that I found, this equation right here, if you wanted to, you can put it into the calculator. And then you can just see when is y equal to 12. So put it in the calculator and see when, look at the table and see when y equals 12. That's another way that you could figure that out. Okay? I got exercise 5 here. The graph of the linear function is shown below. Write an equation of this line in y equals mx plus b form. So I'm just going to look at the graph. Look at graph. I'm writing this down so you guys know exactly what I'm doing. I need an m and I need a b. All right, look at the graph. B is my y-intercept. B is equal to 1. M is my slope, so I'm just going to see change in y. I'm going up 2 over 1, up 2 over 1. All right, so my slope is 2. Y equals 2x plus 1. Nice and easy. Just a quick review of stuff that we've done previously. What must be the slope of a line perpendicular to the one shown? Perpendicular lines, if you remember from geometry last year, perpendicular lines have slopes that are negative reciprocals. So they have negative reciprocal slopes. All right, so the slope of my equation is 2. The perpendicular slope means I'm going to flip it. It's really 2 over 1. I'm going to flip it and also change the sign. So what must be the slope of a line that's perpendicular? Negative 1/2. I change the sign and I flip it. Draw a line perpendicular to the one shown that passes through the point 1, 3. All right, so here's my point 1, 3 is right here. I'm putting a blue dot on that. Now I want to draw a line that's perpendicular. So instead of having a slope of 2 over 1, I have a slope of negative 1/2. So basically I'm going to go down and to the right 2, down and to the right 2, or you can go up and to the left 2, up and to the left 2. And that's my line right there. If I took out a protractor, I could measure that angle. That angle should be a 90-degree angle. All right, so I drew the line. Write an equation of the line you just drew. So I have my point is 1, 3. And my slope is negative 1/2. All right, so I'm just going to plug it into my point slope form. So y minus 3 equals negative 1/2 x minus 1. Done. Does the line that you drew contain the point 30, negative 15? Justify. Well, I'm going to take this equation and I'm going to plug in 30 and negative 15. I'm going to plug in 30 for x and I'm going to plug in negative 15 for y and see if it actually works. So let me do that in a different color so you can see y. I'm not supposed to do y, sorry. I'm plugging in negative 15 for y, so negative 15 minus 3. And I'm plugging in 30 for x. Negative 15 minus 3 is negative 18. 30 minus 1 is 29. And I have negative 1/2 of 29, which is, whoops, let me get rid of that. Negative 1/2 times 29 is negative 14.5. And they are not equal, so no, that point does not lie on that equation. All right, and I have a multiple choice and then just a graph and ask some questions dealing with stuff that we learned back in algebra. That is a little review of stuff that we talked about also in Unit 2. Oops, sorry about that. So let's go here to the next page. A quick, easy multiple choice. Which of the following equations could describe the graph of the linear function shown below? All right, so first off, does this have a positive or negative slope? Any line that starts down and goes up in this direction has a positive slope. So I'm going to get rid of all the negative slopes. And then I just need to know my y-intercept. My y-intercept is down here. Now I don't have any lines on here, but I know my y-intercept is negative. Therefore, it would have to be choice 3. Slope is positive and the y-intercept is negative. All right. And then this last one is a review of some things that you should know at this point. So I want to know the y-intercept. So the y-intercept is right here at y equals 1. My slope, so you can see it's a negative slope, and I'm just going to count. Basically, I'm going down 2 and over 3. See how I went down 2 over 3. So my slope is negative 2/3. My x-intercept, where is it crossing the x-axis? So let me grab a different color. My x-intercept is right here. So my x-intercept looks like it is at 1.5. The equation of the line, I just need a slope and a y-intercept. So y equals negative 2/3 x plus 1. All right, so equation of a line, again, I need a slope and a y-intercept, the first two things I had. The domain are my x values, so I'm looking left, right for my domain. So my domain, is there a leftmost value? No, there's not, so that's negative infinity. There's an arrow, it keeps on going forever and ever. Is there a rightmost value? No, again, there's an arrow, it's going down into the right, but it's going to be positive infinity. Remember, with infinities, you're always using parentheses. You are not using brackets. So my domain are my x's. My range are my y's. So I'm looking up and down. Is there a bottommost point on the y? No, there's an arrow there. So it's negative infinity. And is there a topmost point? Nope, this is going up and to the left. So it is positive infinity. Is this increasing or decreasing? This is actually decreasing because it has a negative slope. It is going down. Where is y greater than 0? So where is y greater than 0? So here is y equal to 0. I'm going to draw a line right here. This is my x-axis is y equal to 0. So I want to know where it's greater than 0. So basically from all the values from negative infinity to 3/2. I am not including the 3/2 though, because it doesn't say y greater than equal to 0, it just says y greater than 0. Where is y less than 0? Again, anything below this line, so anything from 3/2 over, but I'm not including the 3/2, and forever and ever, it's going to be infinity. Where is y equal to 0? At x equals 3/2. And is it a one-to-one function? So for the x's are not repeating and the y's are not repeating. Does it pass the vertical line test and the horizontal line test? Yes. So it passes horizontal line test. All right, the x's are not repeating, the inputs are not repeating, and the outputs, the y's are not repeating.